So relationships between variables. This is one of the basic things that as psychologists we're trying to find, right? Basically when I was giving this, the previous example, does social media cause depression? We want to know what's the relationship between those two variables. If you change social media, will that change a person's depression? That's what we're looking for. So that's what most research does. It's looking for the relationship between these two variables. And other ones is physical attractiveness related to perceptions of intelligence. There's a effect known as the halo effect, where it's been shown that people who are more attractive are perceived as being more intelligent. You'll see this in movies all the time, right? The intelligent heroes are usually the good-looking individuals. The not so smart, bumbling individuals, typically not as good-looking. They're taking advantage of this perception of physical attractiveness and intelligence. So when you ask a question like that, you're asking, do the levels of these two variables vary systematically together? So perceived attractiveness, where is it? Physical attractiveness is a variable, right? There's more or less in different individuals. Perceptions of intelligence is a variable. How intelligent you perceive somebody else to be changes depending upon how they look, what they're wearing, other factors. So they're variables, and we just want to know, do they vary systematically together? Another way to say this is, are physically attractive people perceived as more intelligent? Is the halo effect, actually at work here? Or maybe are physically attractive people perceived as less intelligent? So you always have those cliches. If you watch any sort of like high school romantic comedy, you know that the square-jawed captain of the football team, and you know that the blonde-haired, leader of the cheerleaders, they're not that intelligent in this movie, right? So is that the relation? This is what psychology would try to figure out. So there's basic types of relationships. Typically, they'll fall in one of these four relations. The first one is no relation. This is one of the reasons why we need to use deductive reasoning. Most variables that human beings have, most individual characteristics that human beings have nothing to do with other individual characteristics that human beings have. So if you were just to randomly pick out variables about humans and say, are these two associated? The answer most of the time is going to be no, right? So is intelligence associated with eye color? No. Shoot. Is emotional stability associated with height? No. Shoot. That's why we need deductive reasoning to hone in on, let's look at these variables and let's look at these variables. So the first one is no relation. And what that looks like is if you got a graph that is showing perceived intelligence on the y-axis here, perceived attractiveness on the x-axis, that's what no relation looks like. It does not tell you anything. If you know that somebody is high in perceived attractiveness, they could be high in perceived intelligence, they could be low in perceived intelligence. If you know that they're low in perceived attractiveness, they could be low in perceived intelligence, they could be high. They're not related. And if we were to fit a straight line to this cloud of points, that's what the straight line would look like. It would be flat, indicating that there's no relationship whatsoever. So I kind of skipped this. Hopefully you knew this already, but each of these points is a measurement of the perceived attractiveness and perceived intelligence of an individual. So you would do something like show somebody 100 photographs, and you would say, on a scale of 1 to 10, how attractive are they? On a scale of 1 to 10, how intelligent do they look? And these are the scores that they would get. So each person has 2 scores, and that's where their dot ends up. So that's no relation. That's what most variables actually are. Most variables are not related to one another. All right, so the next relation, basic type, is positive linear. And positive linear means straight. Positive does not mean that this is a good relation to have. Positive does not mean that this is a beneficial relation to have. All that positive means is that if one variable increases, your other variable increases as well. So if perceived attractiveness and perceived intelligence were positively related, positive linear relation, that's what their cloud of points might look like. And if you fit a best line to that, you will see that as perceived attractiveness increases, so too in general does perceived intelligence. And if this was the case, this is your classic halo effect, where people that are more attractive are seen as more intelligent. So more attractiveness means more intelligence, less attractiveness means less intelligence. It's a positive linear relationship. Both variables go in the same direction. One increases, the other increases. If one decreases, the other one decreases. The opposite of the positive linear is the negative linear. The negative linear, again, linear for straight line. Negative does not mean it's a bad relation. It does not mean that it's harmful to a human being. All that it means is that as one variable gets bigger, the other variable gets smaller. So this would be the case if that cliche about the romantic comedies was correct. So if you have highly perceived attractiveness, this would indicate that people in general perceive you as lower in intelligence. And if you're unattractive, people in general perceive you as higher. So low attraction, high intelligence. High attraction, low intelligence. That's a negative relation. When one's going one way, the other variable goes the other way. All right, so those are the first three. We got one more to make you aware of, and that is the curvilinear relationship. And the curvilinear relationship is the not straight line relationship. So these ones here were all best described by a straight line. Curvilinear is something like this. So in a curvilinear relationship, low perceived attractiveness is actually associated with low perceived intelligence. High perceived attractiveness is also associated in this case with low perceived intelligence. There's that sweet spot right in the middle where people are perceived as having the highest intelligence. And this is curvilinear because a line that best fits this is not straight. It has to be curved. And if you fit a straight line to this, you'll actually find no relationship whatsoever, because that is the best straight line to try to fit all of these points. So I'll give you an example of a curvilinear relationship because they're always weird and interesting when you see them. The perception of music liking has been shown, and actually liking in most art has been shown to be on a curvilinear relationship. Okay, so what they've done in this particular research study that they're mentioning is they took a look at the beat patterns of different songs. They took a look at their structures. They took a look at the kind of repetitions and beat patterns of different popular songs. And what they noticed was that there is a certain structure to these songs. So this is a visual representation of those structures. So you have different parts of the songs. You got links between them. You got different, total beats, beats per minute. And that was Rolling in the Deep before by Adele. So this is the structure for Rolling in the Deep by Adele. This is the structure, this next one. That's Paparazzi by Lady Gaga. That is TikTok by Kesha, Fearless, Taylor Swift. And you'll notice that they're basically the same structure. So when somebody, and then this is, just to kind of show you a different structure, this is not a pop song. This is, what do we got there? It's Led Zeppelin. It was Led Zeppelin. This thing's covering it up. So different songs have different structures. And what they found was that the current songs that are popular have a very specific structure. So when somebody who's highly critical of a genre says, well, all these songs sound the same, they're not that off. right? They all sound the same. There's a reason they all sound the same, and that's because of this, the effect, the curvilinear relationship between music enjoyment and music complexity. And this is something that you find in just about every art medium that there is. They've shown this curvilinear relationship. So music complexity, we saw there, is basically how complicated your music is. So some of those structures, like the Taylor Swift songs and the Adele songs, much simpler. Some of the other structures, a little bit more complex. And what you'll find is that for music that is very, very simple, either in how complex it actually is, or in how much you can process it, how well you can process it, that music to us is boring. So this song right here would be something like row, row, row your boat. Row, row, row your boat. Very simplistic, very repetitive. You know, it's just like row, row, row your boat gently down the stream. I mean, it's very simplistic. I'm assuming nobody here has row, row, row your boat on their playlist, right? Nobody works out to, yeah, you do, you jam to row. So nobody here has row, row, row your boat on their playlist because it's too simple. It's just too, it doesn't lead to enjoyment. On the other hand, this is like the polytonal jazz experimental kind of music. The music where you put it on and you'll clear a room because it sounds like polytonal. You don't know that song? I figured if you have row, row, row the boat, you'll have that one too. It's massively complex. They don't use the typical structures. So it's massively complex. People hate it. People do not enjoy that music. What do they enjoy? They enjoy the stuff that's in the middle. So most pop songs, most songs reach the top of the charts. They might be innovative. They might be, really new. They might have a different sound. They're right in the middle of complexity. They're not so simple that you're bored. They're not so complicated that you don't know what's going on. And that leads to the greatest enjoyment. And then this also explains what happens when you get into a genre. So there are people that will listen to those atonal composers. So people like Stephen Reich and the MIT engineers that used to do these computer-generated, types of music. Some people love it, right? Some people absolutely love that kind of music. And you've probably had the experience where a friend of yours has said, oh, you got to listen to this album is great. And you put it on and you're like, that's not that good, right? It's just not good. And then they're like, no, listen to it again. And you listen to it again and you're like, okay, I kind of get into it. And then after 4 or 5 listens, you're like, this is amazing. I don't understand how I didn't like it at the beginning. What's happening is on your first listen to these, you don't have the cognitive structures that are necessary to analyze this music. So it falls here. It's too complex. It's too much for you. But as you get practiced in that genre, the complexity goes down and the enjoyment goes up. So if you're listening to a new genre, a very complicated new piece of music, you'll probably end up here. But as you listen to it, as your mind is able to process it, that complexity goes down. And this curvilinear relationship says that as complexity goes down, enjoyment will go up. That's also why musicals tend to have simpler songs than you'll find in other genres, is because a musical, you need to enjoy it right away. You can't go to a musical and say, yeah, I'm going to shell out hundreds of dollars for this musical, and if I don't like it, I'll shell out another 100 and I'll go back again. And if I don't like it, I'll give it another chance. No, you got to go in and like it right away. That's why most successful musicals, right in that moment. Complex enough that you'll enjoy it, you'll find it interesting, but not enough where you need multiple listens in order to really get into it.